Now let's get into the code. We'll start by just making a new project, naming it color, make sure it's in Python, and creating. Let's start by commenting one thing on our code, our drive motors. For me, they're A and E, and the color sensors. Alright, now once you have that, go back into your code, go into a new line and write wheels, motor pair, AE. Like last time, you can change any part that isn't up to your motors. And then for the color sensor, left color, color sensor B. Right color, color sensor F. Now just like we used the weight last time, we're going to use the weight this time like this. We'll just do wheels.start, left color, wait until color, and then make sure you have in quotes black, wheels.stop. There are more colors you can use instead of black. You can look at those through the library I showed you last time. Now you can go ahead and test this, but make sure when you're testing it, the robot is not already on a black color, and that the color sensor you're using is the one in the code. So make sure your wires are all in the right place. Now you may have noticed how this code only uses one of the color sensors, even though you have two. So now we're going to have it stop if either sensor senses the color. So this one's worded a little bit weirdly, but what we're going to have to do is set up a while left color get color and right color get color are not equal to white, meaning both of these colors are not equal to white. It's just going to be continuing to wait for half a second. Alright, so that means if one of these colors is on white, that means that condition is false, so it'll stop waiting. So for this program, we are having it stop on white. Then once one of these is on white, it'll stop. If you wanted to have it stop when both were on white, you would just swap the and for an or. I know it's a little confusing because of the negatives, but if you can find another way to do it, you can do that. I'm just always showing you one way you can do things. Then once it gets onto the correct color, it'll stop. Now you can swap out the white for black if you don't have a white color already set up. And you can run this and see how it goes. Now time for line follow. Set up this while true. You can replace the true with anything to end the program. I will show you one way to end it in the next program I'll show you, but for now just put it at while true. And then just set up this if right color get color equals black and then have the wheel steer towards the left like this. Then else wheels start steering towards the right like this, and at the very end it's just gonna wait for a little bit. That way it can make sure it gives the program time to catch up, basically. Now the while true is gonna make sure that it's just gonna always be running, because basically what it's asking is true true, and that's basically it's just always gonna be true, so it's never gonna stop. So if you want to stop it, you need to click the button on the robot. But if we put a condition on there, the wheels.stop would stop it once the condition is met. Now once you test this, we'll do a more advanced line follow right here. First we're going to start by setting up the timer right like this. Then we'll add a time.reset to reset the timer before the line follow begins. And then we're going to make a quick variable, just name it X or whatever you want to name it, and I'm going to set this equal to 0 in the beginning. And a variable is basically just a value that you can constantly call back on and change a little bit. If I were to call the X in the program, the X would count as a 0 unless I were to change it to something else. Now for this one, we're going to set up the same type of while, except this time the condition is going to be while time.now parentheses is less than 5, meaning it's going to be waiting until the timer is past 5 seconds. Now for this, we're going to be using reflected light intensity, and reflected light intensity is basically just the darkness of the color you're looking at. And our goal for this is to get between white and black, and when I tested this, my black was 10 and my white is about 100, so I'm averaging it out to 55. If yours is a little bit different, you can shift around this first number to 55 to be anything you want, but you just do 55 minus that get color, and then that's going to be what X equals, and we're going to use the X for the rest of the loop. Now time for the actual movement part. Now the beginning part with speed is not needed, but it will make it more accurate if you do it right. So I just do 55 minus the absolute value of X equals the speed. Then for the steering, you just do X times 1.5 rounded equals steering. Now you can change the multiplier to be anything you want. If you think it's going to be turning too fast, lower the multiplier. If you think it's turning too slow, increase the multiplier. But if you were to plug this in, you would see when the robot is on white, it should be at 100. 55 minus 100 is about -45. So the steering would end up at about -68, and the speed would end up at about 10. Meaning the robot will be turning further towards the center, but it would be moving slower. That way it won't accidentally go over the line and then cause you to have to pick it up. And because of the absolute value, if you were to plug in 10, the speed would still be 10, but the steering would end up at a positive 68. Now if you wouldn't want to use this, you can still use the timer and just forget about the variables and the absolute value and the rounding. But it's all here in case you want to ever use it for your programs. And you can go ahead and test that, and that'll be all for color sensors.